If you're a data scientist or data engineer, or just someone looking to improve your skill set of working with data in Python, now more than ever, there are more options for working with that data. You have Pandas, which is the tried and true data analysis software. Spark, which is extremely popular for working with large data sets, especially at big companies. And then newer packages like Polars, which allows you to do similar actions, but is optimized for speed. So with all these options, which one's the best package to use? Well, the answer isn't so simple, because just like for many things, it's not about picking what's best, but it's about picking what's best for the job. Think of an expert carpenter. They have specific tools to work with each job. Everything from a small screwdriver to humongous power tools. So in this video, we're gonna do some comparison of Pandas, Spark, and Polars. Not only are we gonna look at the differences in the syntax and the way that we use these libraries, but we're gonna talk a little bit about what use cases we would want to use each in. Okay, I hope you're excited. Let's go ahead and take a look at our data set. So here I am in a VS Code Jupyter instance where I've imported Pandas, Polars, and PySpark. Now the great thing about all of these packages is that they were super easy to install. All of them, I just had to pip install them into my Python environment. I also have this flights file, which is a Parquet file with a fairly large data set. Let's go ahead and take a look at this. And we can see here that on my hard disk, this file is 1.1 gigabytes in size. That's a pretty big file, but not too huge. But keep in mind, Parquet compresses the data. So if I use read Parquet from Pandas and I read our flight file, we can see already it's taken a while just to load this data into memory. Now, if I run df info on this, we could see some information about the data frame, like that it's almost 30 million rows. And note here that even though the file was 1 gigabyte on my hard drive, now that it's opened up in memory, it's about 13 gigabytes. I'll also just quickly run a head command so you can see some of the data fields in here. And then we're going to be using these delay columns to calculate some aggregations of both the arrival and the departure delays for each airline. Now, because this data is so large and we're going to do some time comparisons, I am going to be restarting the kernel a good bit. So let's go ahead and start out reading this in again with Pandas and doing that transformation. So restarting my kernel, what I want to do is read in this file, and then we're going to do some aggregations and call this dfag. We're going to group by the airline and the year, and we're going to take these two delay columns, the departure delay and the arrival delay, and calculate some aggregations. Specifically, let's take the mean, the sum, and the max. So let's go ahead and run this. And we can see here, now that it's run, the aggregation has given us the mean, sum, and max of the departure and arrival delays. Now, one other thing I want to do is just reset this index, and then we'll save this result as a Parquet file again as our aggregation file. One thing we need to keep in mind about Pandas is that the data must be small enough to fit into the computer's memory. Otherwise, Pandas is not a good option. So that's always something you want to keep in mind, regardless of speed, that the size of your data and the resources that you have on your machine kind of work together to helping you decide which tool you're going to use. Now that that's done running, let's just go ahead and read the Parquet file just to make sure that we have the results like we would want, and we do see we have it. When we run this using the other packages, it should be the exact same size and we should have these same numbers. But before we get too far with that, I'm going to restart my kernel one more time, and we're going to run time it on this entire cell. This will execute these commands a few times and then show us the average time it took. So our time it is done running here, and you can see it took 7 runs and averaged about 16.7 seconds each time. We can also ls on this output data frame just to see what the size looks like. So the result is pretty small, but it took a lot of computation to get to that point. Okay, let's try using Polars next. So Polars is very similar to Pandas in its ability to do these aggregations and manipulation of data, but it's written mainly for speed. Let's actually, instead of read Parquet for Polars, use scan Parquet. This is one of the benefits of polars because scan parquet will actually create a lazy data frame which won't actually do the computation until at the end when we run collect. And because of that, it can optimize the computation that it's doing and give this our flights file. Then we're gonna have to do our group by aggregation. So we can do airline and year. Then we're gonna aggregate from there. So in our aggregation, we actually provide a list. And our aggregation looks like this, where we call PL call on each column. Then we tell the aggregation type, so average here. And we have to rename this to a new column name. So we use .alias to do that. So here it is all put together. I've done all the different aggregations and renamed them, and we're going to call collect here at the end. And I've executed that cell and we could see the result. These values should be pretty much the same thing we saw when we ran in Pandas. I'm going to restart the Python session one more time and add this write parquet to the end. And let's run time it on this to see how long it takes to run. So this pipeline ran in 1.67 seconds, which is a lot faster than the Pandas version. And since everything fit into memory, polars can handle it just like Pandas. If we do an ls on this output file, we can see the file is slightly smaller, and I think that might be because of the data types of each column after aggregation here. All right, next we're gonna try out PySpark. So for PySpark, we have to import Spark session from PySpark SQL. This will actually create a PySpark instance that's running in the background, and we can create that using Spark Session Builder. Now we've given this an app name called airline example. So now that we've created the Spark session, this is essentially our entry point for interacting with Spark using Python. Now the interesting thing about Spark is it can actually work across multiple nodes of computers. And this is where it becomes really powerful, because working on one machine may not be faster, but the fact that it can scale up to many machines makes the potential for running on huge data sets possible. And that's something you can't get with Pandas or polars, at least not very easily. Another thing I want to show you is now that I have Spark session running, I can actually go to localhost port 4040 on this machine, and I see this UI, which will show me all the jobs that are running on this Spark session, how long they took, and a bunch of other stats. So this can be really helpful for large data pipelines that you're running. You also see here from PySpark SQL functions, I've imported our aggregation types, average, max, and sum. That's because we have to use these functions from PySpark in order to execute it. PySpark does execute lazily, similar to Polar's lazy data frame. So this actually won't run until we've done our final execution, which here is to write to a Parquet file. You can see the syntax has some similarities to Polar's in that we have to aggregate and then rename this alias. But it's important to note that this average, sum, and max were imported from PySpark's functions. These aren't the built-in Python functions. So I'm going to go ahead and execute this cell. Here on the user interface, we could see the actions of the job being run. It'll also list the completed jobs once they're run here. Now, if we ls on this file, we'll actually see that Spark saves this as a folder. So what this basically is a Hadoop partitioned Parquet file. And we see we could read this as if it was just a file. So just to be fair, I'm going to put everything in a time it cell, and I'll restart the session. Note that I did have to add this overwrite mode when writing the Parquet file, so that it would be able to overwrite it each time it runs this time it function. Again, while that was running, you can look in here on the UI and see all the different jobs that are running. And now that it's done, you could see that it ran in about 5 seconds on average, which was faster than Pandas for sure, but not as fast as Polars. Remembering that we're working with data that can fit into one computer's memory, so usually in those cases, Spark is not the best approach. Now, one of the coolest things about using Spark is that you can actually run this whole command without writing any Spark code at all, and instead writing normal SQL like you would on a relational database. To show this as an example, here what I'm doing is I'm using our Spark session to create a temporary view called flights. And flights essentially points to this flights Parquet file, which we had been reading from before. Now I can write normal SQL on this flights table to create our result, and it looks like this. If you're familiar with writing SQL, these type of group by statements are like second nature. So all I have to do is take this SQL I wrote and write it as a Python string and pass this into spark.sql. And then I can chain my commands like before, where I write the output as this temp spark SQL file. And now we can show these files are on disk as this partition parquet file like we had before. So one last time, I'm going to restart my kernel, add the time it. I realized I didn't add the year here to my group by. I'm going to rerun it, adding it back. Over in the Spark UI, we can see all the executions running. So it took about 4.75 seconds per run. Finally, just to make sure all the results are the same, I'm just going to read each of them in using Pandas. And reading in all the results, we can see they're all the exact same shape. And if I just run a head command on each, there's a Pandas version. Here's the Polars version. It looks like it was sorted a little bit different. So make sure we sort them all the same way. So by airline and year. And it does look like the results are exactly the same for the Polars and Pandas version. The column order is a little bit different from this, but you can see the values are the same for Spark. And the Spark SQL version looks like it saved all the column names as lowercase, but the results are the same. So this video gave you a side-by-side comparison of Pandas, Polars, and Spark. You can see how they're all very similar in some ways and different in others. And the tool you want to use is going to depend on the size of your data and the size of the machine that you're running on, or if you're running on a cluster of machines. I hope you learned a lot. If you enjoyed it, make sure you like, subscribe, and write a comment down below letting me know what you'd like to see in a future video. See you all next time.